On your iPad, you should be able to find in the PhET Simulations app a simulation that is titled Reactants, Products, and Leftovers. So you can find that either by searching for it in the options or by looking inside the chemistry category. But once you find this, you'll see that there are three different options: sandwiches, molecules, and game. And I'm going to start off by clicking on the molecules option. Once I'm inside the molecules part of the simulation, you'll start off under one of these three options, and it should be make water. And so in this simulation, you're going to be making different things, or at least seeing for the first time maybe how different things are made. And in this particular option under make water, here you can see a chemical reaction for the production of water. On the right side of this arrow, you see H2O, which you should be familiar with as being water. And on the left-hand side, you might see some of the parts that make up water, like hydrogen and oxygen. In a chemical reaction, you're going to notice three main parts. On the left-hand side, these things are called the reactants. And on the right-hand side, these things are called the products. And the reactants and products are separated by an arrow in a chemical reaction. And so this is an attempt to try to make that chemical reaction more visible to you. But before we start playing with any part of this simulation, I think it might be a little bit easier to switch to the Sandwiches tab to get some of the basics down before we move forward. So now I'm going to switch to the Sandwiches tab. In this part of the simulation, our goal is to try to make this chemical reaction business as simple as possible. So on the Molecules tab, we saw that there was some reactants and a product. And here, to simplify that, instead of making a new molecule, we're going to be making a sandwich. And for this most simplified case, the sandwich is apparently just two pieces of bread and one piece of cheese, and that makes this one sandwich. So in this case, the reactants are the bread and the cheese, and the products are the sandwiches. And so if I put in exactly two pieces of bread and exactly one piece of cheese, then I've made one sandwich. But if I have an additional piece of cheese without adding any more bread, then that cheese is listed on the right as a leftover. And that's because in order to make a sandwich using this chemical reaction, I can make exactly one sandwich only by having two pieces of bread and one piece of cheese. So it's not until I add two more pieces of bread that I make a second sandwich. If I switch over to the meat and cheese option, then here apparently to make one sandwich I need two pieces of bread, one piece of meat, and one piece of cheese. And so if I add two pieces of bread, one piece of meat, and one piece of cheese, I again get one product, which is one sandwich. And so if I have an extra piece of meat and an extra piece of cheese, even one more piece of bread, these things are all leftovers until I add one more piece of bread to make the second sandwich. Alright, and so these first two options, the cheese and the meat and cheese options, were prescribed chemical reactions, where they told you how many of each thing was needed in order to make the product. There's also a custom, where you could play with these options and you could figure out what kind of sandwich you wanted to make, and then you could play around with what you would need to include at the bottom in order to make that type of product that you've selected using the reactants on the left. But what I'd like to do now is switch back over to the Molecules tab and see if we can take what we learned with the sandwiches and now apply it now with these molecules. Now let's see if we can understand how to make a water molecule instead of a sandwich. On the left-hand side, instead of bread and cheese, the two reactants needed to make water are hydrogen and oxygen. When hydrogen and oxygen are in their gaseous form, they exist as diatomic molecules. Di means two, and so a diatomic molecule is a molecule that contains two atoms stuck together. And this happens to be the way that hydrogen and oxygen naturally occur. And so if I have hydrogen and oxygen gas, that can lead to the production of water if they are able to chemically combine. But what you'll notice is that in front of the H2, there's another 2. And so this is an important time where we need to discuss the difference between a coefficient and a subscript. The 2 that comes after the H, that is a subscript. And what that is telling me is that there are 2 hydrogen atoms that are stuck together. What the 2 in front of the H is telling me is in order for this reaction to occur, I'm going to need 2 diatomic hydrogen molecules. And so at the bottom I need 2 of these. And you'll see at the bottom, the moment I add 2 hydrogen molecules and 1 oxygen molecule, I get 2 molecules of water. If we were to continue on with this, you would see that the same thing that happened with the sandwiches will happen with the molecules. So if I add an extra oxygen molecule, it's left over because I need 2 hydrogen molecules in order to make more water molecules. So even if I add 1 more hydrogen molecule, I have enough to make water, but in order for this reaction to work, I need 2 hydrogen molecules and 1 oxygen molecule. So once I add this 4th hydrogen molecule, then I get 2 more molecules of water. And what you'll notice is that in order to make 2 water molecules, I always need to react hydrogen and oxygen in a certain ratio. And that ratio is 2 to 1. And so right now I have 4 to 2, which is the same ratio. And so if I were to bump this up to, for example, 8, how many oxygen molecules would I need in order to use up all of the reactants? And hopefully you've realized that because the ratio is 2 to 1, if I have 8 hydrogen molecules, then I'll need 4 oxygen molecules. Hopefully this chemical reaction business is starting to make sense. Let me summarize quickly the few things that you need to know moving forward. First of all, in a chemical reaction, you start with reactants and you end with products. In order for the reaction to occur, there has to be certain amounts of the different reactants. And sometimes if you have too many reactants or not enough of one of the reactants, then you will be left over with something that might not have been used up in the reaction. And lastly, each reaction is different. So for water, the ratio of hydrogen gas to oxygen gas was 2 to 1. But if you look at the production of ammonia, for example, which is an important molecule for fertilizers and pharmaceutical drugs, the reaction includes nitrogen and hydrogen in a 1 to 3 ratio. And if you look at the combustion of methane, then in order to combust or burn methane, you need methane and oxygen in a 1 to 2 ratio, and when that occurs, you produce carbon dioxide and water in a 1 to 2 ratio. And so hopefully you've learned a little bit about how chemical reactions occur, and we're able to visualize that a little bit using this simulation.